Welcome back to AERO 3170, Aviation Safety, Presentation 14 on Textbook Chapter 14 on the Future of Commercial Aviation Safety. In this presentation, we'll cover future challenges for air traffic management, unmanned aircraft systems, commercial spaceflight, radar limitations, and the next-gen air traffic management system, automatic dependent surveillance broadcast, or ADSB, UAS, and FAR Part 107, and suborbital spaceflight. So what are some areas that may present a challenge for commercial aviation safety? Air traffic management, aircraft design, human performance and safety management systems all may present a challenge in the future. Training new accident investigators and improving academic education. Artificial intelligence will also present challenges. Also some opportunities for future. One of the biggest challenges will be for air traffic management. This will be due to significant increases in commercial aviation travel, and in addition, the explosive growth of unmanned aircraft systems, and also suborbital spaceflight vehicles will strain an already crowded airspace. So airspace right now is managed by air traffic controllers using radar. Radar is a very old technology. It's been around for over 50 years. While the radar systems that we use today are much more improved over what we had 50 years ago, there's still limitations. Radar sweeps an area, and it takes about 12 seconds for a radar dish to rotate. So that means it takes 12 seconds for the radar picture to update. And that requires wider separation between aircraft. In the future, and actually we've already begun, to replace radar with digital technology and satellite technology. But these new procedures need to be introduced slowly and systematically, because we don't want to introduce something that is meant to improve safety, is meant to improve air traffic management, and yet introduce a problem as well. So changes in the air traffic system need to be done slowly and with caution. Unfortunately, aircraft technology has outpaced the technology that's used by air traffic control. Again, some of the radar stations that are still in use were built 40 or 50 years ago. NextGen is the new National Airspace Traffic Management System in the U.S., which is scheduled to be fully in place by 2025. So only 2 more years. The goal of NextGen is to transform the air traffic management system from a ground-based system to a space-based system or a satellite-based system. Satellites in our GPS system give controllers a lot more visibility and also a lot more up-to-date picture of where each aircraft is located. So it allows aircraft to fly a lot closer together. And it also allows aircraft to fly from point to point. In other words, they're no longer required to fly from one ground-based navigation aid to another ground-based navigation aid. So it's a lot more efficient. ADSB, or Automatic Dependent Surveillance Broadcast, combines satellite technology with digital technology. Satellites in space and receivers on the ground give an enhanced position of aircraft in the sky. So it allows for an increase in capacity. Unmanned aircraft systems, or UAS, otherwise known as drones, are aircraft that don't have a human pilot on board. They are controlled by a UAS pilot located on the ground. The growth of unmanned aircraft systems has exploded in the last 10, 20 years due to expanded recreational use, and also new applications used by companies, commercial applications like delivery companies looking to use UAS to deliver products. So over the last 10 or 20 years, we've seen explosive growth of unmanned aircraft systems in the national airspace. There hasn't been a serious mid-air collision yet, but there have been a lot of close calls, and many UAS operators, especially recreational operators, don't have any aviation background, so they're not familiar with aviation regulations or the rules governing airspace. Federal Aviation Regulation Part 107 is the FAR that applies to unmanned aircraft systems. And the FAA and its industry groups have launched an educational campaign called Know Before You Fly. And this is to advise the public about UAS safety. Know Before You Fly was designed by UAS experts to prevent mishaps by educating UAS operators about the Federal Aviation Regulation Part 107 rules and regulations, and operating in the national airspace system. There are 4 areas that are designated as no drone zones. They are airport control zones, so UAS, unmanned aircraft systems, are not allowed within these airport control zones. U.S. military bases, U.S. national parks, and also the area near the White House in Washington, D.C. So these are all restricted. Drones, unmanned aircraft systems are not allowed in these areas. In addition to the explosive growth of unmanned aircraft systems, we are also seeing explosive growth in commercial space flight. Commercial space flight industry is designing and testing vehicles for suborbital space flight that will be used for space tourism and scientific missions. These suborbital space vehicles present a big challenge to air traffic management because they can climb up to 350,000 feet at extremely high rates of climb. And they climb through all levels of airspace and descend back down to the ground in minutes. So a significant increase in space operations combined with the growth of UAS, both commercial and recreational UAS traffic, will increase the demand for air traffic control in our airspace. The U.S. space program includes 3 sectors, and these are important to remember. The first is the civil sector. The second is the military sector. And the third is the commercial sector. Within the FAA, the Office of Commercial Space Transportation is in charge of ensuring public safety and also national security during commercial space launches and also during re-entry. In response to the growth of commercial spaceflight, the FAA developed a concept known as SAT-MS. SAT-MS stands for Space and Air Traffic Management System, and the mission or the aim of SAT-MS is to seamlessly integrate space vehicles traveling to and from space in the air traffic management system. Tracking commercial flights over the ocean has been a significant challenge. There are significant amounts of airspace over the ocean that are not covered by radar. Parts of Africa, Asia, South America, pilots must use satellite radio communications in order to give air traffic control position updates. In 2017, Malaysia Flight 370 disappeared over the Indian Ocean, and the wreckage was never found. Malaysia Flight 370 was a Boeing 777, huge airplane. All 227 passengers and 12 crew members are presumed dead. Now, there is new technology that exists that could improve our ability to track flights over the ocean. Aircraft Communications and Reporting Systems, or ACARS, similar to the ACARS systems that we use right now to communicate with ground stations, could enable us to communicate through digital data links via satellite. Future Air Navigation System, or FANS, is an avionics system that provides a direct data link between air traffic control and pilots. But unfortunately, both of these systems are very expensive and have not been implemented as of today. So what are some other future safety challenges? Well, surface-to-air missiles is a challenge that we may need to address in the future. There have been incidents where a commercial aircraft has been shot down by a surface-to-air missile. Aircraft icing prevention. As climate change progresses, we could see increased need for aircraft icing prevention. Software cybersecurity. As aircraft become more and more automated, of course, computers are handling this automation. We need to be vigilant about guarding the security of the software. Lasers have been a problem in the past and continue to be a problem. Artificial intelligence, of course, we've seen the dawn of new artificial intelligence, and this can only mean more automation in commercial aircraft in the future. And finally, psychological fitness for flight, a challenge that has resulted in a high-profile accident in Europe. We have tried to address psychological fitness for flight. Unfortunately, there's still a lot more to be done. In May of 2015, Germanwings 9525 was deliberately crashed by a suicidal pilot, and there were 150 fatalities as a result. India is implementing a psychological testing program for its pilots in response to the Germanwings tragedy. Why do you think airline pilots and pilot unions have objected to this? Well, there could be potential abuse. It could negatively affect the pilot's career. So it's not something that can be treated without great care. And it could affect your future. It could affect your career in the future. Well, that's the end of presentation 14 on the future of aviation safety. Presentation 14 is the final presentation in AERO 3170, Aviation Safety. I hope you've enjoyed it. Thank you for taking this class.